going to take a look at solving rational equations. Here's an example. The rational equation, notice it has an equal sign in it, and the instructions say solve. Best approach, eliminate the denominator by finding the lowest common denominator. Let's identify the LCD here. So first denominator says it needs an x. Second one says it needs an x squared, so that means we have to bump up the power to a 2. That's going to be the LCD here. Multiplying both sides by that is what we do next. We're going to take that x squared and multiply it one side, and we're going to multiply it on the other side. And the point of multiplying by the LCD is to eliminate denominators. Multiplying fractions is to the right side easier. First, it's easier. Here I have an x squared in the numerator and x squared in the denominator, and a number divided by itself is 1. So those divide out to be 1s. So remember, canceling is division. A number divided by itself is 1. That's how that works. Over here, we have to distribute. I'm going to bring that down to a new line. So x squared times 1 is x squared. And then I'm going to have plus x squared times that 1 over x. I can view this as x squared over 1. And here, remember, x squared is really x times x. And so this x down here cancels with one of those x's from the square, leaving an x behind. Other side, cleaning that up, numerator is 1 times 12 or 12. Denominator is 1 times 1 or 1. Dividing by 1 is kind of boring, so we can just say that's a 12 on that side. On this side over here, see, we replace the x squared with an x due to that cancellation. And so the numerator has a 1 times x. Denominator is a 1. No point dividing by 1. Doesn't change anything. So this is what I end up with. So some of you may be able to skip this middle step here. Just notice that cancellation right away. But on a test or a quiz, it's good to write that down for your brain to confirm, yeah, that looks right. Well, anytime you have a square, think of the zero product rule. We can give 0 on one side and factor the other side, then you might have a chance to succeed. Solve it. So I'm going to subtract that 12. I'm going to write it separately here because 12 is unlike any of the other terms. Means I can't simplify, but I can write down the subtraction. So this is where I'm at. Now, if this doesn't factor, we could whip out the quadratic formula. Think about if this factors next. So 12 factors as 1 times 12, as 2 times 6, or as 3 times 4. And we're looking for a 1 in the middle. Since 12 is really negative, that means subtract the factors. And fortunately, 4 minus 3 equals that 1, x in the middle. So this does factor. Since it's a 1x squared, I can jump straight to the factors and say this must be x plus 4 times x minus 3. The zero product rule says once you have the factors, you can break it up. So either x plus 4 equal to 0, or x minus 3 equals 0. Subtracting 4 from both sides, get x equals negative 4 as one option. Circle out, hoping it's right. Or, adding 3 to both sides on this version, I get x equals 3 as another possible answer. Now, I'm calling them possible answers because I really don't know. All of this work just gives me an educated guess. The only way to know for sure is to plug in and check. So you really have to do that. Check. I'm going to check x equals negative 4, so I have to plug it back into the original equation. So I'm going to give you 1 plus 1 over negative 4. and that's supposed to equal, question mark, 12 over parentheses -4 squared. All right, so we just have to clean this up, do arithmetic. So this is really 1 minus 1/4, which is 3/4. Here, let's see, -4 times -4 is 16, so that's 12 over 16. And let's see, 12, that's even, so let's see, 2 goes into 12 6 times, 2 goes into 16 8, still even, so we can do that again. 2 goes into 6 3 times, 2 goes into 8 4 times, and we got a match. So x equals -4 is definitely an answer. Next, we have to check to see if 3 is. So 1 plus 1 over 3 hopefully equals 12 over 3 squared. All right, so 1 1/3, well, that would be 3/3 plus 1/3, which is 4/3. On the other side, we've got 12/9, and 3 goes into 12 4 times, 3 goes into 9 3 times, and we got another match. We do indeed have two solutions. They won't always both work, it depends. Typical problem is you end up with a number that you think is an answer that makes one of the denominators 0. So that can be a problem. But here we have two legitimate answers. Nice. Moving on. All right, again, solve the equation. We have to identify the lowest common denominator. And it's like 3x is it. That has the x here in common, and there's no denominator there. So we have to multiply each piece by 3x. So we're going to have a 3x times that's -2 over x. And I have a 3x times each of the other pieces. So I'm just going to jump straight to the distribution here. So 3x times 5 over 3x minus 3x times 5. So working from left to right, the x's here divide out. That leaves 3 times -2, which is -6, and there's just a 1 in the bottom, so don't have to worry about that. Over here, I have 3x divided by 3x, which cancels completely. Number divided by itself is 1. 1 times 5 is 5. Switch colors. Minus, nothing to cancel in the denominator, just 3x times 5, which is 15x. Cool, most of the x's canceled. Was that wishful thinking? Nope, they did cancel. All right, so cleaning this up, we'll need to take this positive 5 and subtract it to the other side. So 5 minus 5 is 0. 0 minus 15x is -15x. The other side, I have -6 plus -5, which is -11. Dividing by -15, get the x alone. We get number divided by itself. That's 1. 1 times x is x. And then negative divided by negative is a positive. So it looks like the answer is 11/15. All right, so educated guess, let's hope, plug in to check. So we have a little fraction work to do on our check. Okay, go through it. -2 divided by, I'm going to put in parentheses, 11/15. That's supposed to be equal to, hopefully, 5 over 3 times 11/15. And then minus 5. All right, left side. Dividing by a fraction is multiplying by the reciprocal, so that should be -2 times 15 over 11. Doing that as -2 over 1, nothing cancels here, so I have to multiply. -2 times 15 is -30. 1 times 11 is 11. I'm hoping the other side will lead to that. Here I need to clean up the bottom before I do anything. So let's do that as 3 over 1. And with multiplication, we can cancel ahead of time. So note 3 goes into 15 5 times. So my new denominator there is 1 times 11. 1 times 5 is 11 fifths. So remember, division of fractions means multiply by the reciprocal. So this becomes 5 times 5 elevenths. Minus 5 is still showing out, waiting to be used. Do that as 5 over 1. Nothing cancels ahead of time in the multiplication. So that's going to be 25 elevenths minus 5. So here I need a common denominator to finish it off. Denominator should be 11, so I'll multiply by 11 top and bottom. So that's going to give me 25 minus 55 over 11. And 25 minus 55 is negative 30. And 11 to the denominator. We got another match. We did it. Nice. Next. All right, this one is called a proportion because it's a fraction equal to another fraction. Notice the other problems didn't have that directly. We had that extra minus here. We had the extra plus here. So I could use the same LCD method. If I did that, LCD would be minus 8 times n minus 12. Ultimately, since it's a proportion, I could just cross multiply. So I'm going to do it both ways. Hopefully I get the answer both ways. So first the LCD method, take that and minus 8, minus 12. And that has to be multiplied by both sides. So that's times 6 over n minus 8. That's supposed to be equal to other side multiplied by m 8. n minus 12 times my original 10 over n minus 12. Well, it cancels. Let's see. Again, let's do that as over 1. And this factor of n minus 8 there will cancel with that one, leaving just 6 times n minus 12. Distribute that through, so that's a 6m minus 72. Other side, the m minus 12s cancel, leaving 10 times m minus 8. I'll have to distribute that 10 to each term. That's going to be 10m minus 80. Cool, denominators are gone. So, let's see, why don't we, I guess we can take the 10m to the left. So that's going to eliminate the m's on the right and give me a negative 4m on that side. Now since I brought the 10 that way, I should bring the 72 the other way. So I'm going to add 72 to both sides. You could write that in a second step or leave it there. So that definitely is 0. So that's gone, like that's gone. And negative 80 plus 72 is equal to negative 8. Next, we're going to divide by negative 4. And that should tell us what m is. So m, negative divided by negative is a positive. 4 goes into 8 twice. So I think m is 2. And rather than check by evaluating, plugging that back in, I'm going to check by doing it a different way. So I'm going to use the idea of a proportion. Proportion is where you cross multiply. So what I'm going to do is I'm going to take that 8 minus m and multiply it up that way, and the 12 minus m and multiply it up that way. And when I do that, let's see what we get. 6 times m minus 12 is 6m minus 72. And that equals m minus 8 times 10, which is 10m minus 80. And notice that's that same step we have here in black. So I'm pretty clear it's going to give me the same answer. So I'm going to stop there. Notice the proportion method cross multiplication, a little bit less work, but you can't apply it everywhere. It's got to be, it's only a proportion. You have a fraction equals another fraction directly. There can't be anything added or subtracted outside of that, and there can't be multiple fractions on each side. All right, so I'm going to leave it to you to check by plugging that back in and see if it really does work. Another one. All right, this one's going to be a bit more work. I need to find the LCD, but before I do that, I should make sure it's factored, and I can see this sucker right here might factor. So what does that equal? Blue. 3 factors. That's 3 times 1. There'll be a 1 here and a 3 here. 3 is negative, so these guys have to be opposite in sign. The 2 in the middle is positive, which means the 3 needs to be positive because it's the bigger number. 3 minus 1 is 2. So this must factor as x minus 1 times x plus 3. Coincidentally, I have those same 2 factors over there. So that means the LCD is exactly that pair of factors, x minus 1 times x plus 3. So then we have to multiply that by each piece. So, lots of writing, minus 1 times x plus 3. Don't try to shortcut this, otherwise things go bad, times x plus 1, down parentheses, over x minus 1 equals, take that LCD, x minus 1 times x plus 3. Multiply it by the next fraction, negative 12 over x plus 3. Blue. Right. Plus, same LCD, x minus 1 times x plus 3 times our 8 over minus 1 times x plus 3. And then we get to start canceling stuff, so denominators disappear. Here the x minus 1's go away. Here the x plus 3's go away. And here they both go away. And then we deal with what's left. So in the first one I have x plus 3 times x plus 1. So I'll have to multiply those two together. It's going to give me x squared plus x plus 3x plus 3. Side, negative 12 times x minus 1 is negative 12x. Negative times a negative is a positive 12. And then plus 8. Everything else disappeared. Combining like terms before we move stuff around, you get one pair of like terms there. So x squared plus 4x's plus 3, and like terms here, negative 12x plus 20. So now we're ready to move stuff. Since I have a square, I'm going to move everything to the left so I can get a 0 on the right. So that means I'll have to add 12x to each side, lining up like terms. Now I'll have to subtract 20, lining up like terms. So negative 12x plus 12x is a 0. 20 minus 20 is a 0, so I have a 0 on the right. Other side, I'm going to have x squared. 12 and 4 is 16 on a good day. And 3 minus 20 is negative 17. And 17 only factors as 1 times 17, so this should be pretty easy. It's got to be 17 times 1, and 17 is negative. 1 has to be positive with 1 negative. And here, let's see, 16 is positive, so the 17, the bigger number, must be positive also. 1 must be negative. So again, that's an educated guess, making it all the more important I check shortly. Move over here. So splitting it up, x minus 1 equals 0, or x plus 17 equals 0. That means adding 1 to each side, x equals 1 is one possible answer, or subtracting 17 from each side. And it's worth writing this down just to confirm to yourself you get the sign right, equals negative 17. See, a lot of people skip that step on their work and make sign errors. All right, next we got to check. Same new page. Copy it over. So we think x equals 1 is one solution and negative 17 the other. So if I try to check x equals 1, plugging 1 in everywhere, we get a 1 plus 1 divided by a 1 minus 1. Oh, look at that. Damn. We just tried to divide by 0. No. Can't do that. Can't divide by 0. So 1 cannot be a solution. Makes this whole thing undefined. So backing up, I can now cross that out. That is definitely not an answer. Let's hope negative 17 is. I don't know. Let's plug it in and see. All right, so next, x equals negative 17. So that's going to give me negative 17 plus 1 to negative 17 minus 1. And we hope that that is equal to negative 12 over negative 17 plus 3. Plus, now this next one's more complicated, so I'm going to use parentheses when I plug in. Negative 17 squared plus 2 times negative 17 minus 3. I copy that right. X squared plus 2x minus 3. That looks good. All right, so let's do this side first. Negative 17 plus 1 is negative 16. Negative 17 minus 1 is negative 18. Negative over negative is a positive. And let's see, 2 goes into both of those for sure. 8 times there and 9 times there. So this left side simplifies to 8/9. Hope the other side does the same. What do we got? Negative 12 over negative 17 plus 3. So that's negative 12 over 14. And that's going to reduce a little. Negative over negative is a positive. 2 goes into 12, 6, 7 times. All right. That's 6/7. Interesting. All right, let's hope this works. I don't think I made a mistake yet. Next, we have 8 over 17 squared. I'm going to resist pulling out a calculator. Hopefully you do too. 17 times 17 is 49. 7 times 1, 7 plus 4 is 11. 170. So that's 9, 8, 289. I've got 289. And positive times a negative is a negative. 17 times 2 is 34. 3. So that's going to be a minus 34. 9 minus 4 is 5. 8 minus 3 is 5. 2, and then minus 3 gives me 252. All right. So then I have plus 8 over 252. All right, let's hope 7 goes into 252. Let's check that out and make it easier. 7 goes into 25 3 times. 3 times 7 is 21. 5 minus 1 is 4. And then 2, yes. 7 goes in there 36 times, because 6 times 7 is 42. All right, so that means to add these two, that reduces, doesn't it? Let's reduce it first. So let's see, 2 goes into 8 4 times, 2 goes into 252, 1, 2 goes into 5, twice, with 1 left over, 2 goes into 12, 6 times, 126. Ooh, it's still even, so I can reduce again. 2 goes into 4 twice, 2 goes into 126, 63 times. All right, better. All right, 7 goes into 63 9 times. That means I have to multiply by 9, top and bottom here. 6 times 9 is 54, plus 2 over 63 is equal to what, 56 over 63? And let's see, what goes into 63 and 56? 7 goes into 63 9 times, switch those, and 7 goes into 56 8 times. Whew, that was a lot of work, but it checks. Did it? So we have one solution, but not the other. So I'm just going to recircle this. I got an answer. All right, stay in tune, do good math. See you in the near future.